Right there.
Yes.
No,
Page
on my
135,
arm.
the math note.
Ooh, that stinks.
One quantity is directly proportional to another when the ratio of the two quantities is consistent. The constant is the constant of proportionality, and the ratio is the direct proportion.
Okay. Will, next paragraph.
A direct proportion can be described by a linear equation of the form y equals mx, where m is the constant of proportionality. The graph of direct proportion always contains the origin, since y equals 0 whenever x equals 0.
Can I say the example?
Sure.
For example, in the direct proportion y equals 2x, the constant is
Talking like a
proportion.
Go on.
The constant of proportionality is 2. A graph of y equals x2 is shown in
I'm pretty sure that is 2x.
2x. X. What did I say?
X2.
2x is shown in figure 4. All right, so what's the definition of directly proportional?
To another.
When the ratio of the two quantities is constant.
Okay, write that down. When the ratio of two quantities is constant.
Oh my gosh.
Would you stop it?
Put your elbow on your own desk. In your own space.
Are you a 5-year-old?
A direct proportion can be described by a linear equation of the form what?
Y equals mx.
What variable in the equation is the constant of proportionality? And the slope is the what? What's the slope?
M.
Y equals
mx plus b.
Okay. So the slope gives us what? Describes what?
The ratio.
Rise over run. The change in.
Y of the change in x.
Thank you.
Boom.
All right. True or false? A direct proportion always goes through the origin.
False.
True.
True.
Is it true or false? It's in your book.
True.
These three things are very important to know about direct proportions. We can see them if we see the line in, we can see the equation in the form y equals mx. We'll know for sure that it's direct proportion. The slope, the change in y over the change in x, gives us the constant, and it always goes through the origin. Below are a couple of charts showing direct proportions. Find the ratio of the two quantities. So we can find the ratio of the two quantities looking at what letter?
X.
No.
Y.
What variable tells us m? And m gives us y over x. Change in y over change in x. So to find the ratio, we have to look at our x values and our y values and come up with the ratio. So 0 divided by 0 on your
0.
calculators gives you what?
0.
Does not.
Oh, doesn't it 1?
No.
Divide by 0.
Why is there an error?
Because you divide by 0.
You can't divide by 0. So what we're looking for when we see 0, 0 is that it's going through the origin. We're not going to divide it. Then with the rest of the points, we're going to take the y and divide it by the x to find our ratio or our constant of proportionality. So 3 divided by 1 gives us 3. 6 divided by 2 gives us
3.
And 9 divided by 3 gives us. So what is our constant of proportionality?
3.
It is 3. It can also be written as 3 over
1.
All right, for the other one, 0, 0, we're going through the origin. Now what are we going to divide?
-5 by 1.
Gives us?
-5. Negative.
Next
Oh,
one?
-5.
Next one, what are we dividing?
-10 by 2.
So negative 5.
the last one.
Negative 15 by 3.
is negative 5.
So what is our constant of proportionality?
Negative 5. Or negative 5 over 1.
Or negative 5 over 1. Alright, next we're asked to sketch the graph of each set of points. So we have 0, 0,
0, 0.
1, up 3,
6.
up 2, over 2, up 6, and the other one is not going to be able to be graphed.
Can't graph the other one, excuse me?
The other point, can't graph it. It's off the graph. Alright, next set of points. We're at 0, 0. 1 and negative 5.
You can't even graph anything.
Right.
It's off the charts.
What do you notice about the graphs of each? What are the
They
similarities?
both have a steep slope.
Okay.
One's positive, one's negative.
They're linear.
What does linear mean again? Same.
Y-intercept. They both have an origin.
Okay.
0 is an
Y-intercept
origin.
is 0. Yeah, exactly.
Okay. Goes to the origin. Y-intercept of 0. So if they both have a slope, that means that they have a constant rate of change, right? All right, D asks us to write the equation that would represent each graph.
Wait, the equation?
Yep.
Wait, hold on, I know how to do
equals
this. Y equals 3 over 1x
Okay.
by times
plus 0 because it's
Plus 0. Okay. The next one, y equals.
negative 5 over 1 x plus 0.
Okay. Do we have to include the 0?
No.
No.
Nope.
Determine if x and y are directly proportional in each of the following relationships. Defend your answer. So, in order for items to be directly proportional, what two things have to happen?
They have to have the same slope.
Okay? Constant rate. How do we find the constant rate?
Rise over run.
Divided y by x. And what's the other thing that has to happen?
Has to go through the origin.
Yes, very nice. These two things have to occur. Constant rate, and it has to go through the origin. So, A. Is it going through the origin? How do you know?
Because
It's 0, 0.
there's a line going right through it.
There's a line going right through it? I don't see that line.
It's in my head.
Okay. Alright, so now how do I start finding the constant rate?
Divide by 1.
Okay.
Divide
4 divided by 1.
4.
8 divided by 2.
4.
16 divided by 4.
4.
So is it directly proportional?
Yep.
This is how you're showing your work and defending your answer. You are showing that it's going through the origin, and you're giving me the constant of proportionality. Alright, B. Do we know for sure that's going through the origin?
No, but it will eventually. Like, if you
Yeah, but
figure
you
out.
don't know that for sure.
If we're given a set of data, and it doesn't include 0, 0, can we look at the data and try to determine whether or not? Hi.
Yes.
This is from Ms. Notes.
Okay. Thank you. How can we determine whether or not it's going through the origin?
You have to figure out what it means and then you have to
What if we don't want to graph it? Can we just look at the data?
Yeah.
Can't we just go down to 0 to make it down and put the
Looking at the pattern? Yes. We
so
could.
the next one would be 0. Going down by.
What about y? Can you see a pattern on y?
Well, they're all times 3. No, they're not. Just kidding. The first one you times it by 3. The second one you add 3. And
Okay,
then
x would
next
be 0.
one.
But we don't know for sure.
If you
Alright, so
divide
let's look at the constant rate. Let's see if there's a rate there for us. So, What am I dividing?
4 divided by 2,
Which gives us?
2.
Next one.
12 divided by 4 equals 3.
Next one.
15 divided by 6 equals, 2.5.
Okay. And 16 divided by 8 gives us?
2.
So do I have a constant rate?
No.
And it's probably not going through the origin. So is this directly proportional?
No.
For each of the scatter plots, determine if they appear to represent a direct proportion. Defend your answer.
Yes.
So the first one you're saying yes?
Because it looks like it has a constant rate of change of the slope.
Okay, it has constant rate. What else does it have?
Goes to the origin.
Okay.
Pardon the interruption. Please excuse the girls varsity softball and girls JV tennis at this time. Thank you.
Chelsea.
I got tennis, I gotta go.
You wanna wait? Just I'll be done in like a
Yes.
minute. All right, B. Yes or no?
No.
Why not?
It's all scattered about.
Because it's.
No constant rate. Okay, again, this is defending your answer. Make sure you defend your answer. C. Directly proportional or not?
Yeah.
Why?
Goes to the origin and has a constant rate.
Constant rate and it goes through the origin. What about D?
No.
But it's got a constant rate.
But it won't go through the origin.
All right, your assignment is in your book.
Is it about this?
No.